Hey everybody. This will be the first of a series of lectures, and likely the longest, covering modeling in Rhino and essentially all the basic modeling commands for making the type of model you see in front of you now, which is generally the goal for this assignment. And this covers a lot of the commands that are seen on the second page of the assignment sheet, and hopefully will get you a good start. We'll likely have a second modeling tutorial, which will come in the next couple days, that'll get into more advanced techniques, including some general organic modeling and non-orthogonal modeling that gets to be a bit more complex. But this tutorial intends to be a good first start at what you see in front of you. So what I'd like everyone to do is start by creating a series of layers in their model. Of course, layer panel is on the right here. If you do not have a layer panel at any time, or if it disappears, just type the command layer and it will appear for you once again. All right, mine's already here, so it's right there. I've created several layers, the most important of which, I'm going to move this guy down, are frame, mass, and plane, your basic tectonic elements. Each one of these I've given a color, and in this case I'm actually going to spend a little bit more time picking these colors, as they are going to be the color scheme that I go with for my presentation graphics. So clicking in this case we're really concerned about the square box, not the diamond on the right, just the square box here. Click on it and select a couple different colors for each one, or for each layer. I also have, actually eliminate that one, I have a layer that's named people and a layer that's named circulation. Both of these are going to be useful for you, so you want to create all 5 layers that you see right here: frame, mass, plane, people, and circulation. Frame, mass, and plane, or mass, plane, frame, as you're probably familiar to hearing it referred to as, that's going to be your basic modeling components. So everything that exists in your current physical tectonic model is going to fit into one of those 3 categories. So you'll want to look at your model and categorize each element by mass, plane, and frame, and use that as a way to sort of start assigning layers. So in the model you see in front of you, I'm actually going to right-click in the upper left-hand corner, and I'm currently in isometric view, but I want to go back to a perspective because I find perspective a little bit easier to model in. And again, that's just right-clicking in the upper left-hand corner where the blue box is. Now in perspective view, I have a few other things over there we'll talk about in a second. So this is just a simple little construction that I made for this demo, nothing terribly too fancy. But you can see here are elements that I've defined as framing elements, all on the frame layer. The mass, which in this case, the only mass in this particular composition happens to be the ground, although your compositions may have masses that are beyond the ground. That just depends on your own design. There are some planar elements, which you can see here in the orange. And there is some people. Now these are actually the same people we used in the last assignment. I've just made them into three-dimensional 2D surfaces that I've put into the scene so that they occupy space, will cast shadows, and are accurately scaled for the sake of the image that I'm going to be creating. And then the last thing that I have here is actually this sort of red surface here, which is actually representing the movement path that I am implying that someone would go through to move through this project. It is essentially just a rectangle moved along a curved surface. So this is one of the basic commands of Rhino, which is called a sweep command. We'll go over that in a second. So moving along, our first command that we're going to look at is the planar surface command. So here I have the outline of a person. Again, this is taken from cabblocks.net, the same website we used for the last assignment, but in this case, I've taken him and brought him into this model. So if we go over to the surface command, we have the surface from planar curves. I'm just going to click that. And it actually, you see here, it created the little opening in his arm. And that's because I had both curves selected. So if I only selected one curve and did the same command, it wouldn't leave that opening. But because it understands that one curve is inside the other, it will use that to create the opening in the first to create that surface. Now I can move to my people layer, and he will show up as a nice little person in my scene. So that's very basic planar surface. Next we have what are called primitives. These are the fundamental building blocks of 3D modeling as it was once defined a long time ago, but still exist today. So what we have here are some of these sort of fundamental shapes of 3D modeling: the sphere, the rectangular box, the cylinder, the cone, and this guy whose name is hard to remember. It's a torus. I just call it the donut shape. All of these shapes can be found on the left side here. You have this little pull down next to the cube, and you see all these sort of basic primitive shapes. These are really useful to know because each one of them has many different architectural uses, and they can be combined together to create more complex shapes. Most of the modeling you've seen in Pixar and various other 3D modeling software, or various other 3D rendered movies, all started with primitives that would then deformed into creating the various shapes, faces, people, animals, monsters, whatever it may have been. Primitives have played a large role in what is 3D modeling as it is understood today. But for architectural purposes, and interior design, of course, probably the most useful one is really going to be the rectangular box, because it can be so many different things. Now, if you, again, click on the little right-hand corner triangle, it opens up this panel. And then if we do that again under the box, we're given several different types of boxes. One of these, to me at least, is significantly more useful than the rest, and that's this one here, which is called the 3-point box. The reason being is you draw one direction, you draw the next direction, and then you draw the third direction, or the third dimension. It is just very easy because each one of those you could have put in a dimension. So I can say I want this to be 3 inches, which is quite small in the scale, by, let's say, 1 foot. And then I want that to be 12 feet tall. So that is a 3 by 1 by 12, exactly. Which makes that very useful and very easy to use. If you just click on the box command, it will just ask you for the opposite end or the opposite corner of a box, but you just have a little bit less control, and then you get the height. I prefer the 3-point method whenever possible for boxes. All the others are fairly self-explanatory, and again, their use is a little bit less. So like if you're doing, there's a lot of different forms of sphere. You can do it based on 2 different points, 3 points, 4 points, a variety of different things. I'd recommend sticking with the default sphere because it's based on either the radius or diameter from a starting point. So you'll get that. So next, we're going to look at the Boolean commands. These are some of, and again, some of this might be review for a lot of you. Booleans are definitely one of the more basic things you probably might have been introduced to in spring of last year. But essentially, there's a variety of different commands, and Booleans are really a series of operations that happen. They are a intersection operation, a trimming operation, a splitting operation, and then a joining operation. And depending on which Boolean you're using, depends on the order and how those things are going to happen. So the basic is I'm going to take these 2 objects here and perform a Boolean union. And what that's going to do is make them one object. So if I move this around, it is one object now. They are forever merged until I hit Control Z, and now they're no longer forever merged. The next is we're going to do a Boolean union, or Boolean difference, I'm sorry. Each one of these, and the great thing about a lot of Rhino commands is it's going to give you it's going to ask you for what it wants ahead of time. So if I do a Boolean union, it's going to ask me, what is the object I want to subtract from? So I'm going to say this cube, and then hit enter, and then it asks me what I want to subtract with. I'm going to say this sphere, hit enter, And you can see here I have subtracted the sphere from the cube. So Boolean difference. So there's a few more Booleans we're going to go through. So there's Boolean intersection, which is going to ask you for two different objects. And it's basically going to find where the two objects overlap. So you just get this little edge of the sphere. And then the final one is Boolean split, which let's just do that real quick. So Boolean split. And essentially all it's going to do is it's going to create the three different parts without deleting any of them. So that's a solid object that is the sphere, or the cube or rectangular box with the sphere removed from it, the intersection point, and the sphere itself. Those are the basic Booleans. So the next is a super useful command. Also, if you see me at times zoom to a particular object, I use the command ZS, which also stands for zoom selected. And anytime you do that and hit enter, it will take you to whatever you have selected. So if I want to look at, say, this guy over here, type in ZS and hit enter, all of a sudden I'm looking directly at him. It's a great way of reframing your view, and it's something that I do all the time in Rhino, just so I have a good idea of what I'm looking at. So I'm going to take this object here, which is a box and a cylinder, and I'm going to type in the command array linear. And then I'm going to type in 10. And essentially what it's going to ask me to do is draw out the direction, and it's just making as many copies as I dictated. So I can even do that again. And all of a sudden I have a ton of these things. Now that's kind of in my way right now, so I'm going to get rid of one of them. The other thing that is happening here that I didn't mention is I'm also messing with blocks. So I've sent you guys already to the website CAD blocks. Blocks are a common modeling definition in this software and amongst many others, which means essentially copies of a singular object that remain related to one another. So this little box and cylinder here that I was moving around and made copies of is actually a block instance. And what that means is that if I edit one of these things, so I'm just going to double click on it, it allows me to edit a block. And let's say I just stretch it and hit enter. Every copy of that block will stretch. I'm going to type in the command explode, which will unjoin a block. To make a new block, though, all you have to do is anything you have selected. So I'm going to take this object or this little rectangle here and this thing that I already stretched. I'm going to type in the command block. And it's going to ask me for a base point. I'm just going to give it this point. It's going to ask me for a name. If you're smart, you should name this something, but right now I don't really care, so block 2. This is now made a block, as is defined under the properties block 02 block instance. So if I copy it again, all of these things have identity together. They are the same thing. So no matter how many times I copy this block, any one of them, if I edit it, which editing, all you have to do is just double click, and then it will gray out everything else and will only allow you to edit that particular block. Any edits you make will affect all the other blocks. This is really useful for things, especially in architecture and interior design, that repeat. So if you had, say, an auditorium full of chairs, you'd really want those chairs to be blocks, because every time you make a change to those chairs, it affects every single one of them, and you may have 500 seats in an auditorium. It also is a good modeling practice from the point of view of memory and how well your computer is going to run. Because your computer actually only has to remember one of these blocks, and it just knows the location of all the others. So it just remembers the original, which saves dramatically in memory and can make your model much smaller and much easier for your computer to run if you're using them properly. Next, and again, I'm going to select everything and type ZS so I can make it the center of my orbit again and zoom to it, is the loft command. Just going to type in loft. What it's going to do is show me a line connecting a series of curves. So in this case, I have a set of curves that are stacked on top of each other. They don't have to be stacked. They can be in any particular configuration. Rhino is essentially going to attempt to find a connection between them, then use that to create a surface, as you see here. So this is a good way to do some rather organic and generic modeling. There are several different types of styles of lofts that you can do. So you can do the normal, which you see here, a loose, which uses the curves more as references than as things they have to hold tightly to, as tight, which will hold tightly to those curves, straight sections, which are just straight sections between curves and no longer smoothly curved, and uniform, which is somehow different than normal. So that's loft, very useful for making unusual shapes. Next, we have sweep. Sweep essentially takes any profile, and a profile can be any curve really, and moves it along another curve. So what I'm going to do is I'm just going to draw out something. I'm going to draw out, how about, now I want this, let's just draw a triangle like this. Now I want my profile to roughly match the direction that I intend for it to go. So I'm going to have this profile follow one of these curves here. And actually, it's ideal if it's perpendicular to that curve. So I'm actually going to rotate this. I'll get it close enough. So what I'm going to do is type in the sweep command. Now there's two different types of sweep, the sweep 1 and sweep 2. So first it's going to ask for the rail, which is the curve that you want your shape to follow. So I'm going to hit this, and then it's going to ask for the cross section. So I'm actually going to do the original one that I had, which is this guy first. Hit enter. It's going to ask for essentially the base point, or where your cross section touches your rail. And it usually guesses pretty well, but sometimes you have to move this thing around. So you may have to find that you move this point. But this one's okay. And I'm just going to hit enter. And you can see here, it essentially extrudes that shape along that curve. There's a number of different settings that you can adjust here between road-like and freeform. Those are usually something you might see more when you're dealing with three-dimensional curves. This curve is flat on the surface, but I'll leave it at freeform for now. And then refit to curve, which will keep your shape more consistent. So next I'm going to do the sweep command, and I'm going to do a sweep 2. I'm actually going to delete this guy real quick and do that again. Sweep 2. So it's going to ask for a first rail, then a second rail, and then the cross section. And I'm just going to hit enter. And essentially what it does is it takes this original profile and stretches it between those two curves. So you can see here that we get a shape that conforms to those two curves. Again, a really interesting way to make very unique forms. So just so we can see, we'll do the sweep command. Let's do sweep 1, and then the cross section of this triangle. You can see here, now we've extruded that triangle along that profile, or that profile along that curve. Now just for example, I'm going to make these into three-dimensional curves that are no longer flat on a surface. I'm just going to turn on points on, which is a very useful general command, and make these things into 3D curves. So I just pulled them up on the Z-axis. So let's do this sweep 1 again. Use the basic rail, and then cross section, hit enter. And you can see here now it just follows that curve up and along that curve. Now we can see the difference between road-like, and freeform. Essentially, road-like will always keep that curve flat, or that profile flat, while freeform will just kind of follow the curve as it sees. So in this case, I would use road-like. So that's sweep. The next we're going to do is revolve, which is exactly what it sounds like. It's a great thing about Rhino is half the time, if you don't know what a command is, you can probably guess it because they are ruthlessly logically named. So revolve, it's going to ask me for a curve to revolve, this guy. It's going to ask me for my axes, which is this one here, and then my rotation. And I just did a 360 revolve, so I just created this little shape here. It's a good way to make a vase or something similar to a vase, or yeah, that sort of thing. Columns, lots of things like that. A very useful command. Next I'm going to go over is one of the nice editing commands called move face. If any of you are familiar with SketchUp, this is basically the SketchUp command. So move face, and essentially what it allows you to do is you select any face on a surface, or a polysurface in this case, and it just allows you to move based on that. Pretty simple. The same thing for move edge, which allows you to select an edge and enter. And so there's a constraint often set up here. Mine is currently set to vertical, which means I can move it up or down, which can be very useful. So let's try that again, except I'm going to turn the constraint off. If you want to turn your constraint off, just click on it up here. We can do none, first face, second face. Let's just do none. And now we can do some weird things with it, which the reason why you might want to keep it on is to avoid this situation where it tries to keep the surface consistent even though you've done some weird things. In this case, really pull that one edge out very far, and the surface is trying to stretch itself to form to it. Next is a very basic one. It's just called pipe. And it does exactly what it sounds like, which is it will take any input curve and it will make it into a pipe. It just asks you for the beginning diameter and the ending diameter. So this is very useful for making, say, chords and tension, round columns, steel members that are circular and in unusual shapes, but that's the basic pipe command. So those were your sort of basic commands. This example file here, which I'm going to select and do zoom selected or ZS, this was really primarily constructed with one command, which is the primitives and the Boolean, or not the Boolean, the rectangular box 3-point command. Because most things in architecture and most things that you're probably representing in model form are rectangular shapes in essence that maybe get cut or angled or something like that. But if you're representing, say, the tiny sticks that you might have built your model out of, that's really going to be the command that you want to be using. So this red path here is the path that you see, and it's really just that same sweep command that I did. And how I made it was essentially going to the top view, looking down on my little creation, and I did one of the curve commands. I'm just going to open this up and do the curve interpolate points, and just draw out some points that I think is the path that I'd like people to move through my project. So I just drew that on, well, you can see here it actually went a little crazy because it snapped to some things, so it's actually a very three-dimensional curve. It's probably not what I want, even though it is actually very interesting. I'm just going to undo it and do that again. When drawing from the top, I'm going to turn on the project little toggle down here, which means it'll always be on the 0 axis of the z-axis, meaning it'll always be on the ground. So no matter what I snap to, it won't be floating in the air. And now if I go back, I can see here that my curve is now moving through that space. So I already have a profile, but I'm just going to draw another one. Let's do just a basic rectangle. So this is why the alternate views that you see here, the perspective, right, and front, are often very useful, is it allows you to snap to vertical axes. And now I will do the sweep command. Sweep 1, and then cross section. And voila, I have this thing moving through space. Now, one thing you may notice is the way I did it doesn't ensure that the profile, the width of the sweep was consistent along the entire length of it. And you always get some weird conditions here, especially where it made a really tight turn. There's a couple things that you may want to avoid. Really tight turns are definitely one of them, especially for a profile that is much longer than that turn. And then the other thing is, the closer you are to being perpendicular to the curve that you are following, the more likely it is to keep its shape. So I'm just going to rotate it to match that curve, and then just rotate it again to be perpendicular. Just typing in 90 degrees. So this curve is now perpendicular to, or I'm sorry, this profile is now perpendicular to that curve, so it can follow that along and will make the most consistent profile moving through space. Now the people, this guy here that I showed earlier, once I stand him up, and of course he is scaled, he is set to be 6 feet tall, I believe, or 5'10" or something close to it. I'm just going to move him into place. Oops, see here, I didn't snap to anything, so he's beneath the ground. I might snap to an edge first, and then use the gumball to move him exactly where I want. Now, because I know that I'm going to be doing an axon, which is going to be aligned here, I'm actually just going to rotate him to 45 degrees. And I know I'm going to want negative 45. That way, when I make the axon, he's perfectly facing the camera. Looks like I brought his curve with him. So that's the basic modeling commands. Again, I'm going to do another video at a later point that will go over more advanced commands, including some more abstract and organic modeling. The one last thing I will cover here is, of course, good layer management is always going to be really important, so make sure you keep that in mind as you start this process. If you ever want to just, you have a bunch of curves and you want to get rid of them, there's a few things that are really useful. The command purge will essentially get rid of, in this case not curves, but it'll get rid of layers that you aren't using, hatches that you aren't using, line types that you aren't using, materials that you aren't using. It'll just clean up your file. Sometimes this will get rid of things that you want to keep using. So it's a good thing to do maybe once you come to a good saving point and you can save the file, then purge, and it'll just get rid of all the excess stuff in your file. It'll help on memory and file size and a bunch of other things. The other is SEL followed by anything. So if you see here on the left, it shows a whole bunch of different commands. So I can do SEL CRV, which is curve, and it will select every curve that I have drawn in the model. So all of these curves instantly get selected. So if I want to say select all the curves and move them to a particular layer, I could do that. Or if I want to select all the curves and delete them right away, I can do that. So I could do SEL block instance, and it'll select all the blocks. Or SEL, let's try polyline or polysurface, and it'll select all the polysurfaces. So SEL followed by anything is often a really useful command. Another is I'm going to select, say I have this whole model full of junk, things I've been working on, but I really want to focus on just this particular piece, just this guy here. So I've already told you about ZS, or zoom selected, which just brings your focus to it, but those guys still exist in the background. There is the hide command, but the easiest way of doing it is if you go up to this light bulb here and pull down the little triangle in the bottom right hand corner, you have this command, which is the isolate objects. If you click that, what it'll do is hide everything else that you don't have selected. So the only things that you get to see are the items you're working on. So maybe it'll be that you're working on just this piece here. So you don't want to have to worry about the rest of your model. So now you can zoom in and work really detailed on this one piece. And all you have to do is right click the light bulb and everything else shows back up without having to delete anything or mess with any layer management. You can do the same thing with locking. So again, let's just say I wanted to work only on that piece. I'm really focused on that layer of construction. I could do the isolate lock objects, which essentially makes everything else go gray. I can't select it. I can't do anything else to these objects. All I can work with are the things that are currently in bright colors. And these objects just stay locked. To undo it, just right click on the lock command up here, or the gold unlock, but I think just right clicking is easiest. Okay, so that's going to cover the basic modeling. I will have a follow-up video that is going to cover setting up display modes and outputs, and then a follow-up to that, which will be Photoshop.